All right, welcome back to another math video. Today we're going to continue our adventure on trig in the standard position. All right, so we have started the last two questions here. This ties into today to do a few special angles and their corresponding trig ratios. These are only two of them. And there are a few more. You need to you need to know by heart. Okay, so first one is this angle here, 0, 1, 0, 5. Let's draw the arm. Hey, initial terminal. What angle is this? If you remember, it's on the y-axis, so this is actually 90 degrees. 90 degrees. Okay, so let's draw another angle with the same reference angle. We need to know what the reference angle is. It's technically on the cut of quadrant 1 and quadrant 2, so either rules would work. Probably easier with quadrant 1, so the reference angle is equal to the actual angle, which is 90 degrees. Can we think of another angle which is also 90 degrees? You're probably thinking the same things I am, and that angle is actually 270. Remember, reference angle is the angle made with the x-axis, so that angle is 90 degrees. Okay, so the whole angle is 270 degrees. So a angle with some reference angle, right? 270. Theta r is 90 degrees as well. 90 degrees as well. Now, if we apply the cast rule, right? On the top, all is positive here, sine is positive here. Okay, so we expect sine to be positive and sine to be negative down here. Okay, cosine, same thing, on top. Most likely cosine is, wink wink, wait, cosine is negative here and positive here. So what can cosine possibly be there? Okay, right in between positive and negative. I wonder, what about tangent? Tangent is positive here, negative here as well. Okay, well, let us take a look. Okay, let's start with the reference angle or the base angle here of 90. Remember, r is x squared plus y squared, so r is equal to square root of x is 0 squared, y is 5 squared, but 5 squared is 25, so r is equal to 5. Wait, that's equal to y. Well, that's fine. No reason why it cannot be. Okay, let's take a look. Sine of 90 degrees is y over r. So y over r, which is 5 over 5, equals to 1. Nice. Sine of 90 degrees is 1. Cos of 90 degrees is x over r, but x is 0. So it's 0. Cos is 0. That solves the problem, right in between positive and negative. But what about tangent? Tangent is y over x, but y is 5x over o. Okay, dividing by 0, no. So it's actually undefined. The symbol means undefined, or the empty set. Okay, so this you are expected to know, or you can drive it. I showed you how to drive it. Okay, or you're expected to know that sine 90 is 1, cos 90 is 0, and tangent 90 is undefined. So with that same information, we can do the same thing with cast rule combined. Of course, I'll draw cast rule again. Right, with cast rule, we can also conclude that sine of 270, it's on the bottom half. Sine is negative on the bottom half, so it's negative 1. Cos of 270 is still 0, right? Positive 0 and negative 0 are both 0. And tan of 270 is undefined. Okay, so you'll expect to either drive this or know this as well. Okay, but probably easier to remember the 90 degrees and then drive a 270 later. You can drive a 270 later. We're gonna do a same. I'll let you do the same thing here. I'll let you do the same thing here. This time the angle is actually 180 degrees. Okay, 180 degrees. What are trig ratios? Just to help you out, answer this question, the reference angle is actually 0 degrees. And our conclusion is sine of 180 is 0, cos of 180 is -1, and tangent, okay, tangent 180, okay, is equal to, well, r is 1. R in this case is r and x are equal in this case, so it's actually -1 as well, because x is negative. Okay, x is negative. So that's for that. Okay, when zeta is equal to 0 degrees, though, sine of 0 is 0, cos of 0 equals to 1. I actually made a big mistake here. Tangent of 180 is also 0, and tangent of 0 degrees is also 0. I made a mistake here. Okay, 0 over -1. Okay, oh, spoilers, that's how you calculate. So I revealed the answer, but I would like you to try this activity out for yourself. Okay, and figure out where these numbers come from. So I'll skip the graphs. Combining the CAS rule and our special angles, we can actually fill in this chart, right? Fill in this chart. I'll do one by example. Sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. 360 has the same reference angle as 0 degrees. Hope you take my challenge from an earlier video. So it's equal to 0, so it's 0 again. Okay, quadrant 1 is positive. Quadrant 2 stays positive. Quadrant 3 is negative. Quadrant 4 is negative. Back to quadrant 1 after 360. Okay, I guess I'll do a little bit of graph. So if you do sine, it actually looks like this. So 90 degrees here, to 0, to 0 at 180, 270 to -1, and back to 0 and 360. Okay, but I digress. Okay, fill in this chart for yourself for review. But the reason I did those triangles in this video instead of last one, okay, is because I want to talk about all the special triangles, special angles. The one we just did is 0 and 90 degrees, but in fact, there are 3 more: 30 degrees, 45 degrees, and 60 degrees. Okay, you are expected to memorize these trig ratios, okay, for those 3 angles, but there are a lot of them, 9 of them to be specific. That's a lot. So it may be easier to remember these special triangles instead of remembering the actual trig ratios. I'll let you attempt these 2 exercises out, which drives the ratio in detail. I'm just going to give you the answers. Okay, the triangles you should know. First triangle is a isosceles right angle triangle. The all right angle triangle here. That is not isosceles. It's not isosceles either. Let me try one more time. Otherwise, I'm gonna just use it. So 45 degrees. So that looks more like 45 degrees. There we go. Okay, so this is 45 degrees. Okay, because they're isosceles, so these 2 sides are the same. These are the same. Let's just call it 1. Then we can use Pythagorean theorem to find the third side. This side is 1, 1. The third side is square root of 2. So it's square root of 1 squared plus 1 squared equal to square root of 2. So opposite is 1, adjacent is 1, hypotenuse is square root of 2. So it does allow you to remember it fairly quickly that sine of 45 degrees is opposite over hypotenuse, 1 over root 2. Exact value, okay? You need to remember this exact value. Cos of 45 degrees, because it's adjacent, is hypotenuse, is opposite, same value. It's also 1 over root 2. If you know how to simplify this into square root of 2 over 2, that's okay too, but I will accept both answers. And tangent of 45 degrees is 1 over 1. So 1. So that's the ratio. And how do you remember it? Remember I'll draw it over here. 45. This might be easier to remember because these are isosceles. It's a 1, 1, root 2 triangle. 45 degree is a 1, 1, root 2 triangle. Okay? And then the second special triangle is a 60-30 triangle. 1, 2 triangle, I actually call it. This one is 30 degrees. This one is 60 degrees. And the ratio, I usually remember it this way. The shortest side opposite of 30 is 1. Hypotenuse is always 2. Then we're going to use Pythagorean to find the bottom one. Then we find the bottom one using square root of blah, blah, blah. And we get square root of 3. Okay? The bottom side, the other, it's not hypotenuse. Hypotenuse is 2. This is hypotenuse. This is short. It's 1, 2. Then I can always drive square root of 3 using Pythagorean theorem. But with this triangle, we can actually calculate the trig ratio for 30 exactly. Okay, sine of 30 degrees, opposite is 1. So it's 1 over 2. Cos of 30 degrees is equal to, well, adjacent over hypotenuse. So it's root 3 over 2. Tangent of 30 degrees is opposite over adjacent. It's 1 over root 3. If you know how to simplify this already, I'll accept that answer as well. Now, it's correct. But if we just do a flip, if you remember, okay, all we need to do is flip the adjacent and have opposite. We get the same thing for 60 degrees. We just flip it around. Sine of 60 is root 3 over 2. Cos of 60 degrees is 1/2. And tangent actually is a full flip. Tangent of 60 degrees is equal to square root of 3. Exactly. All right. So these are the special triangle ratios. You need to know them. It's not on your formula sheet, which means you're actually expected to memorize them in some way. Once again, I do not recommend you memorize the ratio the hard way, okay? But you can memorize special triangles. It will help you, okay? Need to know by heart. Hopefully, by the time you actually spend practicing these questions without a calculator, okay? No calculator. You remember them quite well, all right? The two examples I skipped go through exactly where these numbers come from in greater detail. So let's do a question. We are not going to do a clock problem. We're just going to go straight to a picture problem right here. Okay, let us do sine of 330. Okay, I'll lead you to do cos of 135. All right, sine of 330, which quadrant is it? Well, it's bigger than 270. And of course, it's less than 360, as they normally are. So 330 is probably in this quadrant here. Okay, so boom, 330 degrees. It's in Q4. All right, so step 1, always determine the sign. So it's using cast. It's in Q4. It's in quadrant 4. So sign is negative. Q4, Q4 means sign is negative. So right away, we can determine sine, I'm going to write the answer in black. So sine of the value, sine of 330 degrees is equal to negative something. Okay, negative something. I guess I put that in blue. Then step 2, we want to figure out the value, or zeta r. So zeta r is the angle make with the x-axis. So that's my reference angle. I'm even going to go ahead and draw the right angle triangle here. Okay, zeta r. Zeta r, of course, in Q4, it's 360 minus 330 degrees, which is 30 degrees. So that is my reference angle. So we know the reference angle we're going to calculate the value with. Okay, I'll write down zeta r is 30 again. Okay, if you remember from last video, the trig ratio, the value-wise, is the same. All it differs by a sign, which you already have. So it's sine of 30 degrees. Now that I know it's negative sine 30, now I can calculate the exact value because 30 is a special ratio. So I know sine of 30 is 1/2. So the answer is negative 1/2 because sine 30 degrees, I remember the ratio is 1/2. I did not remember this ratio over one day. I did not remember this ratio over 2 practices. I remember this after doing countless practices, okay, and using trig over and over again. You are still expected to remember this all the way into university. So these are some great ratios and triangles you should remember, okay? 2 triangles you should remember. When I ever forget, okay, I remember the triangles. I didn't actually remember the ratios, okay? I just have done so many of it that I can do the calculation in my head, okay? But spend some time with it, okay? Spend some time with it, and you can actually calculate quite a variety of angles with exact values. You'll only be expected to find the trig ratios of these special type of angles, okay? You now know the special angles are, special reference angles are when zeta r is equal to 0 or 30 or 45 or 60 or 90 degrees, okay? Do you know the trig ratios? Do you? Okay, that's one. If anything that's really hard in this half of the unit, it's this. Okay, it's actually this. No, their trig. Do you know their trig? Just like do you know their, I forgot the reference. Never mind. Okay, do you know their trig? Okay, so that is today's lesson. We have a very short lesson left, how we can do the reverse we've been doing. But if you watch the video so far, know how to find the trig ratio of an angle. Okay, trig ratio of an angle if I provide it to you. Going backwards, I give the trig ratio, calculate the angle yourself. Should be very easy. You just need to use sine inverse, cos inverse, etc. as an operation on your calculator, or you remember the exact values. Okay, but that will be our next video. And with that, thank you for watching. Okay, this wraps up how to find the trig values for an angle. Okay, our next video is the reverse. All right, and with that, thank you for watching. Have a good day.